Hello and welcome to this session on future value of annuity. This is the fourth session in the series of sessions on time value of money. So in the previous session, we have seen what an annuity is. An annuity is a series of cash flows with the following features. The cash flows are uniform, that means the size of cash flow is same. The first uniform cash flow occurs 1 year from now. Uniform cash flows occur every year for a specific number of years, and this is the nature of an annuity. Whereas an annuity due, which is also known as immediate annuity, is an annuity that starts now. So the only difference between an annuity and annuity due is in an annuity, the uniform cash flows start one period from now, whereas in annuity due, the cash flow starts from today. We also saw that when the nature of cash flows is such that the annuity is first appearing, which is followed by a bulk cash flow at the end of the period, we apply the concept of future value of annuity. Now let us see how to compute the future value of annuity. There is a shortcut for computing the future value of annuity. One way of doing it is to compute the future value of all the amounts and add them together. But there is no need to do that. You can apply this formula where future value is defined as A multiplied by 1 plus R to the power of n minus 1 divided by R. Here, A represents the uniform annual cash flow. R is the rate of return, N is number of periods, and again there is an R coming as the denominator. Whereas, if you are looking at an annuity due, the only difference between the formula of an annuity and annuity due is future value of an annuity due is calculated just like an annuity. The only difference is we multiply with 1 plus R once again. Therefore, future value of an annuity due will be A multiplied by 1 plus R to the power of n minus 1 whole divided by R into 1 plus R. Now let us look at an example. An investment scheme offers 7.5% interest per annum on a recurring deposit scheme. If one invests 10,000 every year in this scheme for 8 years, what will be the maturity value at the end of 8 years? Now, since this is an investment scheme, you have to start investing today. Therefore, since the first cash flow happens today, this is an annuity due. So what is the nature of cash flow here? Starting today, the person will be investing 10,000 rupees every year for the next 8 years. At the end of 8th year, this entire amount will be received back along with the interest on this as the maturity proceeds of this deposit. And that is what we are going to calculate. In order to calculate that, we apply the formula. Here A is 10,000, R is 0.075, number of years N is 8. So if you apply this formula, you can find that the maturity value of this deposit will be rupees 1,12,298.50. Let us look at another example. An investment scheme offers 8.25% interest per annum on a recurring deposit scheme. If one wants to receive 7 lakh at the end of 6 years, how much should one invest every year in this scheme? That means I want to receive 7 lakh rupees at the end of 6 years from now because I need 7 lakh for some purpose at that time. And I am interested in depositing uniform amount every year into a recurring deposit scheme for the next 6 years so that at the end of 6 year I am able to receive 7 lakh rupees as the maturity value. Here again, This is an annuity due because the investment starts today. Now, if you substitute the values, the future value will be 7 lakh. What we don't know is the annual installment. So A into 1 plus 0.0825 to the power of 6 minus 1 divided by 0.0825 into 1 plus 0.0825. If we solve this for A, that means we calculate this and solve this formula for A, we will find that the value of A is 87,594.47, which means if I invest 87,594.47 every year in the scheme for the next 6 years, at the end of 6 years, I will be able to withdraw 7 lakh rupees as maturity value of this deposit. So in both these cases, you have seen that the annuity happens first and the bulk cash flow happens at the end of the period. Now, what happens if the frequency of cash flow is shorter? That means we are not investing every year, we are probably investing every 6 months or every quarter or every month. Here, the concept of multiple compounding has to be applied. You will remember, in case of multiple compounding, the rate of interest R should be divided by the number of times compounding is done in a year. For example, M will be 2 for semi-annual compounding and M will be 4 for quarterly compounding. So we divide R by M and then multiply N by M. The number of years in the formula should be multiplied by number of times compounding is done in a year. So this is the only change that we need to make. Wherever R appears in the formula, we should convert it into R by M, and wherever N appears in the formula, it should be N into M. So let us now look at one example. The interest rate offered on a monthly deposit scheme is 7.5% per annum. If an investment of 5,000 is made every month for the next 5 years, what will be the maturity value at the end of the 5th year? Now it is monthly deposit. That means every month 5,000 rupees is deposited. The interest offered by the scheme is 7.5%. And like this, the investment is made for 5 years. At the end of 5 years, how much can I withdraw as maturity value? So this is also an annuity due, but with monthly compounding. Therefore, here M will be equal to 12. And the formula will be A multiplied by 1 plus R by M to the power of N into M divided by R by M plus 1 plus R by M. Here you can see that wherever R appears in this formula, we have taken it as R by M, and wherever N appears in this formula, the N has been multiplied by M. Let us now look at this formula, substitute the numbers and do the calculation. Here A is 5,000 because I am investing 5,000 rupees every month. Interest rate is 7.5%. Therefore, it is 1 plus 0.075, that is 0.075 is divided by 12. To the power of N is 5 years, N is multiplied by 12 divided by 0.075 divided by 12 into 1 plus 0.075 divided by 12, it comes to rupees 3,64,902. That means every month, if 5,000 rupees is invested for the next 5 years in a scheme offering 7.5% interest, at the end of 5 years, I will be able to withdraw rupees 3,64,902. So this is how multiple compounding is brought into this formula. If it was semi-annual payment, we would have taken M as 2, and if it was quarterly deposit, we would have taken M as 4. That brings us to the end of this session. The sessions coming up after this session are present value of annuity, equated monthly installment calculations, which is very important, And finally, you have seen a lot of formula being used in all these equations. You don't have to really remember those formulae because there are wonderful MS Excel applications which can be applied for calculation of future value, present value, etc. Therefore, the last session in the series of time value of money sessions will be an MS Excel application for time value of money. So we will continue this discussion in the following sessions. Thank you.